So, TPM myths. This is one of those areas that I will often end up ranting about at some length, because a lot of people have some very widespread misconceptions about the TPM. Some of them are because early on, when the TPM was still a star in Microsoft's eye, there were some marketing materials that put out some very unusual, some not really accurate ideas about what the TPM was for and what it could do. Some of it are from certain privacy activists who got a hold of those early marketing materials and went on a campaign. And so if you Google for TPMs, it won't take you very long to find the lengthy rant about treacherous computing and how terrible it is. It's completely inaccurate. It has nothing actually whatsoever to do with realistic threats that the TPM does and doesn't pose to people. But it's what most people see because it's the first thing that pops up. Of course, many of those folks have edited the Wikipedia page. So there's misinformation coming from those sources. And again, they got a lot of that from the TCPA back before the TCG existed, when it was giving everybody the wrong idea about what TPMs were for. But in general, it's because this is a tremendously complicated topic. Somebody summarized it, and the summary was misinterpreted. These things happen. So I'm going to debunk some of the most common myths and talk about what the truth is behind them, and hopefully that will be a little bit of fun as well as useful. So the first myth is that the TPM can stop your machine from booting if bad software is running. We get this one a lot. The problem is the TPM has no actual control over the rest of your machine. It is completely passive. It responds to commands, and that's it. You can turn the TPM off, boot the machine. The rest of the machine isn't going to notice. You can leave the TPM on, boot the rest of the machine. TPM will notice that the power's on, notice, it will get its information. It has no mechanism to reach out and say, stop. It has no awareness of what's going on beyond what people tell it. So if you manage to, if you turn off all of the measurement software somehow, TPM doesn't know, TPM doesn't care. Not only that, even if it did, the TPM has no idea what good means. What the TPM can do is limit access to particular data to good software. Remember what we said about PCR access to encrypted data. Remember what we've said about hard drive encryption, for example, using encrypted symmetric keys. So we can, in high security situations, if we can manage to get around that PCR fragility issue, we can say we'll use the TPM to limit bad boots. BitLocker does this. On the Linux side of things, there's something called tboot, or trusted grub, which you can configure to stop boot if certain hashes don't match, and those are stored in PCRs. You can use device encryption that supports the TPM. There's some hard drives that talk about doing this. But the thing you need to understand is none of these stop the machine from booting. They just stop you from getting access to the old data. I can boot a BitLocker machine where the hard drive is completely protected from a live CD. I'm just not going to have any hard drive space to use. So there's for many purposes, when somebody says, I want to stop the machine from booting badly, this is good enough. I want to stop the machine from booting badly because I don't want somebody to get access to my sensitive data or my sensitive software. The TPM can help with that. I want the machine to not boot badly because I don't ever want a user to think they can safely input their passwords when they're wrong. That's a lot harder because now the user needs to have some confirmation that there's some data there that was decrypted that would not be available if the machine were in a wrong state. This is sort of the penguin picture idea, but you have to be deliberately setting out to say, I want the user to confirm that the TPM is in a good state, which is a much harder problem because people are not actually very good at cryptographic operations. I have no trusted path to the TPM, so I'm looking at a monitor. I have no way of knowing if the machine booted properly, except in as much as I've noticed my data is not available. A lot of people say, "Hey, great, the TPM is tamper-proof. I can just go get it and go use it." TPMs are tamper-resistant at the consumer level. Sorry about the LaTeX errors there. They're tremendously good return on investment. These things cost less than $1, and that huge, big publicized, "I broke a TPM and I got its keys out" break from a couple of years ago destroyed a dozen TPMs in the process and cost more than $100,000. We were utterly astonished. The TPM researchers have been saying for years, you can break one of these things with a screwdriver in a college electronics lab. We were wrong. They're actually a lot harder than that to break. But if you work for the government and when you talk about tamper resistance or tamper proofing, you're thinking about a nation state. This is not really designed for a nation state. A nation state probably can't afford to throw $100,000 at breaking a TPM. They are very, very good for what they are, and they're effectively free because they're in all of your machines. But we don't really recommend these if what you're looking for is high. I had somebody who said, "I want to put these in high security buoys so that the Russians can't get them." And I went, that's not really what these are for. Also, that's certainly an interesting application, not really the TPM's design use case, Yes, you do require physical access. No, not as far as we know. All of the attacks on TPMs today that we know of take the form of, in terms of getting the keys out, take the form of etching.
Physical access.
Yeah. It will destroy the TPM. But once you got the keys out, who cares? So this is one of the myths that the privacy activists will plug day in and day out, which is that the TPM doesn't work for you, it works for Disney or Microsoft, or insert the corporation of your choice that you decide is sketchy and terrifying and good for a horror story. So this grew out of some of the early TPM publicity, because one of the applications the TPMs were originally pitched for was digital rights management. And the original story was, so Disney wants you to be able to watch Snow White on your laptop, but they don't want you to steal Snow White, so they're going to hand you a video player, and they're going to say, we'll only ship you the movie if we confirm that you're using our video player on a trusted software, trusted OS that we approve, and if not, you can't have Snow White. Well, realistically, this is not actually the best use for TPMs for several reasons. One of which is that the TPM really does belong to the machine owner. You can turn it off if you want to. So Microsoft will be able to track my machine and track what operating systems I boot. You can just turn the TPM off. I can use different identity. We can track things from machine to machine. I can't tell that you're the same person watching Snow White as turning in IRS things. But on top of that, remember what I said about those PCR values being fragile? Good luck trying to figure out in a consumer context all of the possible good values for an operating system. There's no way Disney can solve that problem. And even if Disney could solve that problem and could reliably say, you're running an approved version of Windows that Microsoft told us is good, and you're running the Disney movie player, it costs $100,000 to break a TPM. Digital rights management of this style, where I want to protect my intellectual property. Some pirate, one person, needs to break one TPM, and all of a sudden the data is on the loose. This is not really at all good for that kind of high-value intellectual property protection. It can be very useful in terms of digital rights management in an enterprise context, where I want to say, I want an audit trail for a document, or I want to limit distribution of a document. But that's partly because in an enterprise context, the users are reasonably trusted. And if somebody loses physical access to a machine such that it goes into a lab to be etched, we expect to be notified. That's a very different world than the consumer world of digital rights management, where really the owner is assumed hostile. So, but this myth and all of its associated concerns are the main reason the TPM has so many privacy features, is trying to back away from my machine is no longer mine, the TPM works for Disney. We also get a lot of people who want the TPM to be a cryptographic coprocessor, because after all, hey, we've got a cryptographic chip on motherboard now, this is great, this is wonderful, except for the little piece where it is cheap and it is slow and it is highly constrained. That highly constrained bit is great for preventing a whole lot of attacks, but it also means that it is not actually very easy to drop TPM crypto into existing applications. Most existing applications are not yet. See X509, they expect you to be able to use the same key for encryption and decryption as well as for signing, or they expect you to be able to sign data in any arbitrary format, and the TPM doesn't do that. The TPM has higher constraints. And of course, because the TPM is so cheap, and why is it so cheap? It's because they had to persuade the platform manufacturers to include it on every single machine. This is not an expensive chip. So performance really did fall by the wayside. There is really no way you can use a TPM for things like signing individual packets. It's just not fast enough. If you actually want high-speed crypto, get something else.